Good morning, everyone. Ram just texted me that he will join 10 minutes after.
Hey guys.
Hello. Okay. Can
So
you hear me?
yeah, I can hear you. I can hear you. I
Okay.
heard your comment about Rom being will be
Okay.
late.
I had a new headset. I wasn't sure if. Okay, now I see that. Um,
So I've done some cleanup on the document. Very minor changes. Just some small rewording. No big changes. Um, in terms of like things to do on this call, um, there are a lot of comments I've been looking at, going through that probably need to get turned into um, action items and things like that. And then there's some things that I added, a while back in terms of comments that are, um, I don't know what they mean. Like I found, as a good example, there's like at the bottom of the document, there's like a to-do list, I guess. What was it? Not, it was basically, I think just meetings from the minutes that got captured but didn't get put in the document. And I've gone through some of them and put them in a document, but I need to go through all that list and double check. There's like 12 items, but specifically the last 3 items, I'm not sure what the intent was. They're on page 20. Here, I don't see if I can share. I'm in an airport right now, so I'm not 100% sure my bandwidth's going to be friendly with this. Um, okay, can you guys see my window?
Yeah, it looks great.
Oops, I scrolled too far. There it goes. The last 3 items here, 10, 11, 12. First one is the link layer needs to support non-credit based link layers. I'm not sure what that means in this context. Because the link is the main band I think we're talking about, right? I don't think we ever use the term link to refer to the sideband. And so if this was the case, I don't know why this document would care about credited versus non-credited buses on the main band.
Yeah, so I don't understand that comment either about where it came from, but I agree with you.
Okay.
yeah, I don't know where they come from.
All right. Moving on to number 11, trash messages that are the wrong ID registers, suggestion to firmware. It's like, I think this is kind of half a thought. I'm not sure what exactly that means either. I'm not sure who wrote this list either. I don't know if this was Boppy or Rom or somebody else.
Yeah, my guess is it came from Boppy. Again, I don't know what that really means, but my guess is it means you're supposed to throw away messages that have the wrong address, especially the ones that go to the sideband control registers, where we kind of said we don't really need an address for that thing. But I think
We do have address. What do you mean by that, actually?
well, so what happens if they're the wrong address?
Yeah, but I know what you mean by there. But what did you mean by the other part where the sideband control registers don't have an address?
No, they do have an address. That's what I was saying is they do have an address and they don't need to have one. We agreed that they don't need to.
Oh, sure, sure, sure. Okay. Um, okay, yeah, I don't know. Do we want to define behavior if you have a bad address? I assumed other people would just map other registers into the space that they felt like they needed to, for, system management or whatever. Um, um, do we need to have address error checking, I guess? We're not defining any other errors. So I guess that's another part of that too. So if we define that there needs to be an error in this case, then we're straying into that territory too. We can add a note saying address is not covered in this, the effective address is not covered in the spec is undefined. Or, up to the implementation, whether an error is raised or if any other functionality is observed.
So
Something
we
like
do
that.
have an error command and we can send an error message. I don't think
Right,
we
but we're
can
not
write
defining
it.
error values though, or what needs to be an error, right?
Yeah,
I mean, we
we
have things
left
that
it open.
can, yeah, we left it open. I'm just saying that if we make this an error, does that open the door for us defining other errors? Or do we need to like just keep it vague?
Oh, calling this particular error out?
Yes. The only other thing that we say that is an error kind of is, sec dead errors, but we don't really say what or where those are reported or how you respond. I mean, in a normal system, a bad address could be nothing, or it could be, it could be eaten silently, or it could be a bus error, So it's kind of system dependent and undefined anyway.
What do we currently say about parity errors or?
We don't. We just say that, I mean, we say that there's ACC, right, to detect issues, but we don't actually say that that you're supposed to raise an error or anything like that.
Okay, I'm not saying that's wrong. We should probably be consistent. I agree with you here that if we open this up and start trying to say something to do about like address errors, then we probably should do that for other things as well. And I just don't think we want to go there.
Well, we do have a section on the address map. Again, we can add a non-committal statement there saying accesses to addresses not in this register map is implementation specific, which may include error responses.
So in error handling, in agreeing that we don't want to be specific about errors and leaving it to the implementation, we kind of add the last paragraph in the error handling in this spec and said that it is up to implementation how to report that error. And it can be any type of error. I'm not sure being a wrong ID address makes it more critical to call it out.
Yeah, I mean, I'm fine either way. Saying this is an error. We don't. We just need to be careful how we word it with the other stuff. Yeah. Okay. So let me add a note to myself here. Oops. And addresses out of bounds may report errors. Um, Stupid small keyboard. Um, let me put the thing. Okay. All right. Let's move on to number 12 here. So
I'm sorry, before we do that, do we say anything about our recommendation for ECC errors? So forget about what we're going to say in the spec. Do we intend to report those to firmware? How do we say, I'm sorry, do we save the message that has
we,
so firmware can see what happened?
we don't say where. We have 3 error reporting mechanisms. We don't say which errors go where. We don't say explicitly what needs to be an error. And we don't say, obviously, anything about error values or error format.
Right.
There are a number of things that definitely could be errors in this. And we do say things like, you know, I think there might have been something in the ECC section, but we don't really, there's no cohesive thing. Let's see, let's move up to what he was saying. Error handling. There is a EG, missing addresses with bad ECC.
Right. So I'm more talking about our implementation, our preferred implementation, not what we say in the spec, but like when we get an ECC, any message with an error, right? Do we forward that message to firmware? Can firmware see like what happened?
Oh, yeah. Well, okay. I don't know what everybody else's opinion is, or the spec says nothing, but my expectations, yeah.
Yeah,
Right.
I would say firmware deals with all errors.
That's right. Any message received with an error should be forwarded to firmware, right? That's our assumption.
That would be
So
my assumption.
the message itself doesn't get, I mean, may or may not get forwarded, but the error indication definitely has to be indicated to firmware, because I think if you look at it, I think there was a local register, error register. I'm not sure if that is still there, but we would log any ECC errors in the message packet and immediately interrupt the firmware on the receiving side, saying that we received a sideband packet that had an ECC error, which was not correctable.
Right. That's all well and good, but I'm saying we should have the raw message as well available to firmware somewhere. Right? It's fine to say we got an ECC error, but it'd be nice to see the details of it.
Okay, so then we'll probably have to have, I mean, along with the error register, maybe we'll probably need an error log register of sort, which would probably be 3 or 4 registers combined, assuming a 64-bit system.
Yeah, I mean the whole message, yes. Yeah. And I'm not saying we need to put that in the spec here, right? I'm happy to leave it implementation dependent, but it just seems to me that's certainly what I'm doing, right? Is I'm forwarding all problems to firmware, and I send the entire message to them, right? Because again, just saying there's an ECC error is like, begging a bunch of questions. And I just want to make sure you guys were in tune with that, right? That you agree that that's a reasonable
Yeah.
amount.
Well, given we don't actually say anything about how errors should be handled, I'm not sure how you would code that in hardware without taking a risk, right? So I think pretty much everything has to be in firmware at some point in terms of error handling.
So the spec today does not prevent what you're doing, Paul, right?
Correct. So that's what I was also going to comment. I mean, from a spec perspective, I think we are specifying the bare minimum that is needed. That is to interrupt the firmware to say there was an ECC error. But then it is implementation specific, depending, I mean, if a certain implementation wants additional logging, they are free to add additional registers where they can do additional debug of that error. But I believe that would probably go into an implementation note, or I'm not even sure if we should even specify that, because that is individual vendor's choice.
Yeah, and I'm happy to leave it that way too. I like the error handling section being lightweight for us. So I'm encouraging us to stay that course, I guess. I'm not trying to muddy the waters here, sorry.
Okay, so
I feel like I need to add another statement here saying that there are other kinds of error handling, but I need to brainstorm that and think about it for a second. Okay, so right now, at least there's nothing we need to add there, right? I'm going to add a second thing on the address, in the address section, say behavior and undefined. But I mean, is there anything else we need to explicitly add? Okay, it sounds like the next one's kind of related. So check that if a higher level PMR message is not completed, ability to signal error, yes. Does that mean if you get an error trying to complete a PMR command?
how
we
would
need
you,
another?
sorry, Brian, how would you check? I don't think we have a check mechanism, or
Yeah.
maybe
No.
Wouldn't that be a message back to the? Oh no. If a higher level PMR message is not completed.
So
So,
I believe the PMR message, I mean, each PMR message has a bit that says whether an act is required or not. So I don't think we have set this protocol up to work as a polling mechanism, but more like a inter mechanism, if you have to maybe sort of that once you send a PMR message to the other side receives it. It does some certain operations based on that PMR command. And then if the command indicates that an ACK is required, then it needs to send back an ACK saying, I've done whatever you have requested. So I'm not sure if we need an additional polling mechanism to see if that got completed or not.
right. So what happens if you time out for the ACK then? Is that what this really is about?
Yeah, I mean, we'll probably have to put a timeout, yes. So, and timeout could probably be at either side. So that would probably result in a error. And most of this, since it is used in calibration bring up, what it would result in is calibration error.
Okay.
so let me repeat to make sure I understand. So the goal is that, if I understood what you mentioned, Ram, the goal is that the link partner, we wait for the link partner and then we call it error or not. If it's read, the read response doesn't come out, timeout happens. If it's a write, the ACK doesn't come out, error is flagged. Is that, but I think this sounds to me as if this is more error handling locally.
No, so the read and write is a different timeout. So this is basically a PMR commands, right? So all PMRs are writes. So you write to the partner's PMR message, PMR register saying, say for example, you're in a bring up state, and you want the partner's transmitter to transmit a certain pattern, so that on this side you can start some calibration on the receiver, right? So you tell the partner, okay, now start transmitting this so and so pattern. Now the partner receives that command. The software interprets it. It knows it needs to initiate the transmitters to send a certain pattern. And once it configures the transmitter to send a certain pattern, some of the PMR registers would also indicate that an ACK is needed because the other side is waiting. So if an ACK is needed, once software is done on the other side, it will send a PMR message saying I'm completed. You can go to the next step. Now, I believe that this point, what it is talking about is what if that ACK never came? So there are two ways to handle that. So one way is both sides run a timer, and the other side would also know that the timer expired and it was never able to send out an ACK. The side that originally requested will also be running a timer, saying it is waiting for an ACK PMR. And if it never received an ACK PMR, then it can flag an error to its software saying RX calibration could not be completed because the partner never responded.
Understood. So the ACK is explicitly specified in the PMR. Did we ever talk about timeout? Timers and timeout?
Yeah, I don't think we spoke about timeout. So I think Brian brings out a good point that we probably have to specify some timeouts so that we do not hang ourselves.
And that is only in the context of PMR.
Yeah, I mean, that timeout could, like you mentioned, right, that timeout could be specified at multiple places. So PMR is one place where when we send a PMR with ACK, we probably need to run a timeout. The other places is non-posted write. If we have a non-posted write and we are expecting an ACK, we never received an ACK, we probably need a timeout. That would probably go under the protocol error. The PMR one is more like a higher level error, but we could also have some protocol level timeouts where you mentioned there could be a read or a non-posted write for which we are waiting for an ACK, but we never received an ACK. So we'll probably have to also specify a timeout for that so that we don't hang the sideband infrastructure from doing anything. Like, for example, if sideband transmitter sent out a read command, the receiver is waiting for the read response to come back. And if the response never came back, we may put the hardware in kind of a waiting state, and the hardware can stay there hung for a long time. So we'll probably need to specify a timeout to say if the timer expires, then just go to the error state and recover yourself.
I mean, there's some related errors too. Like if you have, like if the transmitter violates, the outstanding protocol, rules or whatever, or if if you get like, back-to-back transactions without the associated acts in there being sent from the other side, right? Obviously, there's a missed packet or something, and so there's a couple of protocol violations you can lump into that same bucket. So we don't need to enumerate them, right? We started kind of enumerating them. I just deleted all that text. But we probably need to kind of generally word it saying, hey, there, for things like that, you may do errors or you may track timeouts. I guess the question specifically for timeout is, do we want to set a number? And do we want to call out, because like you said, Rom, it can happen in multiple places here, either at the sideband protocol level or at the higher level, linked protocol PMR level. Do we need to call it out in both places, and do we need to add values for time in both places? There was a mention about something like that.
Yeah, I'm not sure if we can. I mean, probably we can add a value to the timeout, but that would probably need to be configurable. If I recall correctly, I thought we added some configurable timeout at some point. I don't know if we still have it, but
so there's a note here saying 94 nanoseconds. Is that meant to be the maximum time a transaction can take?
Right. So that 94 nanoseconds is basically, since we are serializing the packet, right? So we have 94 bits to transmit on serial.
Okay.
So on the other side, the receiver has, so say the receiver receives the first packet, it is going to receive the next packet only after 94 nanoseconds. So if we can guarantee that it can service the first packet before 94 nanoseconds, then we are all good. But if not, then what we agreed that we will throttle the or rate limit the transmitter and add delays in the transmitter to make sure that if there are back-to-back requests, the transmitter waits before it sends the next request until a time that receiver would take to process the previous one.
Okay. Yeah, that seems really small for a timeout. Okay. So all right. So your other statement was obvious. So we need both a timeout and we need to be able to configure the timeout. Do we need to have a register for setting that, or is this just a firmware behavior we need to call out?
I believe it could just be a firmware behavior because most of the sideband transmitter is firmware driven. There is very little hardware involvement. So we could probably add the weights in firmware instead of adding additional gates. And I need to go back and check that 94 nanoseconds because it feels as if we are missing a zero there.
That would make more sense. But I mean, well, I mean, it depends on what you're trying to assume that happens in that 94 nanoseconds.
Right.
Again,
I mean,
if you're saying
right.
just
So,
that the other side has received it, and is starting processing it, that's
right.
fine.
Right. I mean, I was doing a rough math in my head. So we were running this interface at 100 megahertz, which means it's a 10 nanosecond clock period. And we have 94 bits to send in the packet. So it will take minimum of 940 nanoseconds.
Yeah, but so
Okay.
you can run up to a gig, right? So that's just your implementation. So we should change that from being an absolute number to being the length of one packet.
Agreed. So we decided to run sideband at 1 gig.
No, I'm saying the spec allows that.
Allows to go to 1 gig. Okay, I see. Yeah. So yeah, I mean that number needs to be based off of what the spec requires. I mean what the clock frequency we are running at. Um, and I'm not
So-
sure. I mean, if the
Well-
spec allows different clock frequencies, then we may probably want some speed negotiations as well, right? Or we just assume that both sides by design will operate at the same frequency. Is that the assumption?
We're also not we're not 94 bits anymore. We're like 100 bits with ECC, right? So I mean,
Correct, yeah.
I guess the point though is that we need to define this in clocks, right? And say within 94 or 100 or whatever those clocks, from start of transmission, the receiver needs to start processing the packet, right?
Correct.
So that you
We
so
can
that
probably
you
put
don't
it
end up
as
with a
a
delay.
correct. We can instead of putting an absolute number, we can probably make it a function of clock period. But we should also mention somewhere in the spec, call out somewhere in the spec that both sides need to operate at the same frequency. Otherwise, again, we would end up missing some bits if they don't, or maybe not. Since this is not a UART protocol. Sorry, I take that back. It's we are transmitting the clock and the data, so it doesn't matter what frequency we are operating.
Yeah,
I mean,
true. There should be no requirements that the links run at the same rate.
Got it. Yes, I agree. I mean, I was kind of biased with how I had implemented it, and mine was a single wire implementation, so it was a UART based. So both sides need to know what frequency it was.
I mean, we can just say the receiver needs to always be able to receive packets, always, because there's no. I mean, I can say both. I mean, I'll start adding some of these. Started processing some of these to-dos and add statements there, and then we can review them in a sheet for meeting. Wait, was there something else on timeout that we needed to cover? Oh yeah, we didn't have it. A number. Do we need to add a number there, or just say? Are you, Ron? You were saying the timeout needs to be configurable.
I think making it configurable is probably the most flexible because each system may have a different response time. So making it configurable and configuring it to whatever the system response time is probably a better idea.
Okay, so this brings up the other point that you were mentioning in terms of polling behavior. So again, we have two possible areas where you time out, both the sideband protocol, which is rating on, various forms of ACK, or at the PMR, which potentially be weighing on a PMR ACK. In both cases, do we need a solution for polling the status of the other side? In the PMR case, it would probably be a new PMR command, like, what is the status of, I don't even know what the options would be there. I guess processing or not processing, right? And if you were doing it at the sideband protocol level, we'd probably need another command there as well. Some sort of status poll or something that again basically says the same thing. Do you have an active transaction or not?
Right. So since this protocol was supposed to be a very low speed protocol, reads are usually very expensive to do over this sideband. So I mean, if we want to do polling, maybe that could probably be a part of a debug methodology. But I think it shouldn't be a part of production firmware because otherwise this would become too slow.
I agree. I think the only reason you poll is if your timer expires, right? And you're trying to figure out if the other side is hung or you know, if it's just taking a long time because it's going to external memory or whatever the case may be.
No. So you will be running a timer locally. So the timer is not on the other side that you need to go look at.
No. Like, okay, let's say I send a command and request an ACK from a PMR command, right? And I
Right.
don't get the ACK back. What's the next step?
Right. So if you don't get the ACK back, then that PMR command failed. So you will indicate to your side software saying that the PMR command didn't go through and it timed out.
Right, but I
And
don't
then-
know if the other side is still processing the command and it's delayed, or if you know, or if it actually failed on the other side.
Right. So the timeout window needs to be large enough to unanimously conclude that something wrong happened. I mean, it cannot.
Okay.
The timeout duration cannot be such that you are right at the boundary where you time out, but then the other side responded back. It
Right,
needs
but
to be a large enough value. So we'll probably have to put that in the spec thing. It needs to be configured to a large enough value that if the timer expires, then I mean, there is definitely something that has gone wrong. I mean, that would probably keep the spec simple. What do you think?
yeah, I'm fine if we don't want to add a polling mechanism. I'm just asking if people think it's needed. Does this make sense? It needs to be large enough value that the expiration of the timer means a critical failure.
Yeah,
Yeah. Paul, you're okay with it, right?
yeah, I think that's wonderful, Ram. I really like your proposal.
Okay, thank you.
Do we want to put a number there as a suggestion, like 5 microseconds or something? I don't know. I don't even know what a number would be there. Again, I guess it would depend on clock and a bunch of other things.
Correct. Yeah, I mean, it is very hard to put a number, right? Because every system would probably operate differently. So, I mean, if you want to keep the spec flexible, then we'll probably let the spec software writers or the implementers call that out.
Okay. All right. Well, I'll add some text on this and we can review it next time then. Okay. Oh, right. So there was so other things, again, I didn't highlight them here, but there was some notes about needing a needing to find into the Hamming table for the SecDed implementation and things like that. Do we need to specifically call that out, or do we want to refer to a specific ECC standard? I don't know. Is that NIST or whatever? Are we calling that out anywhere? Yeah, change this one.
Yeah, to me, it seems like we ought to put the parity table in here, just like we do for the link layer spec, just to avoid confusion.
Yeah, I think in one of the meetings we agreed that we will probably just put the SecDed table in here.
Right, or maybe not a table, but just the equations, you know, something so they don't have to go somewhere else to find something and potentially get lost.
Someone want to volunteer to do that? I'm not sure which one we're using or anything.
Yeah, I actually picked up a code from GitHub, so I can probably send you the link if you want.
Okay. Is it something I can copy paste or do I need to rock it?
I'm not sure. I mean, GitHub is open source, so I think it should be okay. I can send you a link offline, and then
Okay. All right. Well, send me a link offline and I'll take a look and we can make a call.
Okay, sounds good.
Um,
Can you just can you, if you don't mind, leave a assign a comment to me that I need to send it
yeah,
to
let
you?
me go back up here. There was another comment that was by something. We'll check. Somebody else called the same thing out, and I want to make sure that we're all together. 7, nope. It was all the way up here as in the sidebands. I need to add Hammond coding image. Oh yeah, you already tagged. I'll tag you again.
Oh, wonderful. Okay, thank you so much. I'll address it.
Oh, why can't I add? Oh, there it is. All right, I tagged you again. Yeah, if you could just add a link there in the comment, about which one you think we should include, and I can take a look and copy it in or format it or whatever. Okay, there was one more I remember. I don't know if I can squeeze this in there. That was back down on this other section. It was like a half completed thought of a statement that didn't make any sense. I wanted to make sure that anybody had any context on it. There it is. No messages have been defined for the blank. I'm going to guess that people
That's
have.
delete. I'm gonna guess that's delete.
Okay, just checking to make sure there's nothing I'm missing there. Okay, all right. Oops. My mouse is doing here. Okay, all right, let's go on. All right, yeah, we can. I think that's the end of the ones I knew that I had right on deck. I think we if we want to, we can review some other comments. So I think I've started clearing out comments that I know are resolved in the document, and we kind of need to make sure that we clear out the rest of the comments as we go forward. And probably use that as a good way of tracking progress in the document. Does anybody have any other things that they really want to cover this week? I guess. I'll just go back up to the top here. Oh, I think the rest of this stuff at the top, I'm going to end up
That will be
deleting.
deleted. Yep.
Yeah, so I'll go ahead and delete it and make sure that anything that we missed is covered down below. And then we'll use the comments as the tracking mechanism. Let's see. Oh, yeah, okay. I'll add that later. Let's see. We don't have like a state machine diagram or anything like that. We need to include, right? And we talk about oh, that was another thing I changed recently. I moved the link states down into the link protocol subsection to keep, so you don't end up reading about main band link states before you learn about the sideband protocol. So that'll probably get a little reworded, but I guess the one question there is, do we need is there any diagrams that we need there, or are we just assuming that the inferred unidirectional table is adequate? Trying to get out of that section. I don't think we need a diagram.
Yeah, I like tables because we can edit them more easily and keep them updated more easily.
All right. Laziness wins then. Okay, so I'll remove that comment about that. So there's other comments here. Let's see. State machine. Link repair. Do we need to add link repair to this list? Anybody have a opinion on link repair?
Sure, I'll throw one out.
Um,
So my opinion is it should be implementation dependent. It seems like the way people implement repair is implementation dependent. And so attempting to explain how to do that in a specification, I think will just be ugly.
As this comment mentions, do we need to mention where it happens?
Yeah, I'm trying to think what was the context for that? Maybe we can mention that the link repair, what Paul mentioned, the link repair is implementation dependent.
I don't think we can keep it implementation dependent, right? Because we need to provide how we set the link repair muxes because both the transmitter and receiver need to be aligned on what lanes to use and if they need to fall back to a repair lane. And they need to follow the same mechanism. So yes, while it is implementation dependent, if both sides don't implement it in the same way, then we won't be able to achieve a successful link repair.
Well, I think we don't need to necessarily define how link repair works here, right? Because we're not defining how any of these other stages actually work, right? That's for other specs. We just need to define that as a stage, right?
Correct. That's what I think. Yes. It is more of a phi function, and it is usually it will be taken care of as a part of the phi bring up. That's the most efficient way to do it. But yeah, from a PMR perspective, I'm not sure if we have to leave an additional state for link repair. I believe it would be handled as a part of that link bring up functionality
Okay.
or the
So
slice bring up.
should we make a note here then?
Well, yeah. So so getting to isn't a slice bring up thingy, right? Isn't repair on a per slice basis? Each slice has its own redundant lanes.
Correct. I believe so. I'm not sure how
There's
the
already a note there.
I don't go back to.
There's actually a note there. Any lane repair occurs here.
Ah, there you go. I think that's more than sufficient.
I agree.
Okay, I'll just close this comment then. Let's see, maybe make sure that we come link tuning. Okay. And so I guess the only real question is we don't need any additional messages in terms of PMR that mention that link repairs needs to happen or is happening, right? It just happens suddenly as part of the slice bring up, right? I'll take that as somewhat consensus. I'm going to close this comment as completed.
I'm good with that.
But here, well, you know what? I need to add. I'll add a note saying what it was. Okay.
Yeah. Well, it seems like there's two ways I guess to handle this, right? One is that we just know from manufacturing what link needs to be repaired. I think the transmitter and the receiver need to agree on which lane needs to be repaired. And if it's not hard coded in some non-volatile memory somewhere, then, you know, we have to figure out that live by doing, you know, link training.
Yep.
And the only person who knows now which link is broken, sorry, lane is broken is the receiver. Right? So the receiver has to back to the transmitter which lane needs to be repaired.
So that happens through the PMR. So once the PMR, if the receiver is not able to calibrate on a certain lane, it is expected to send back a PMR message saying it was not able to calibrate a certain lane, and then we fall back to a lane repair mechanism.
Okay.
So, so let me just capture that real quick. So repair information is transmitted to the PMR, but it's implementation specific in terms of a message. Is that right, Ron?
I have to go and look at the PMR table. I thought we added something on those lines in that giant table that Papi has.
Okay.
I can dig into it and send you a pointer to it.
Oops. All right, I tied you on that.
Okay.
Let's see. Let's move on to add row for sideband link exiting reset. This may be placed in the main band link spot. Sideband link. Helga, what does that mean?
I'm trying to remember the context that I added there.
Which one? Okay. Oh, it's right. It's entered at power up or when link is at reset. Okay. Add a row for sideband link exit.
Oh, I think this is a how does it come out of reset? When I was going over that, I think I couldn't figure out how does it come out of reset. And then I think I figured out, but it wasn't in this table.
Okay. Do we need to add anything, I guess?
So this table, is there a version of this table in the main band?
I don't remember. Let me see if I can.
I think that was. Okay, I'll try to figure out why I wrote that there.
Yeah, I don't.
Yeah.
I mean, there's probably some mention of some of this stuff, but it's not. The terminology is not the same. Anyway, so yeah, if you can Yeah, I'll ping you in as a comment here. Let's move on. Which row is a table to apply to sideband versus main band? Like, I think we all know what those are all main band. Hopefully the reorganization of the document makes sense. Though I need to go back through and just reread everything being the end to make sure that it's oh, okay, yeah, so I need to, just as an action on me, maybe do that. I need to add a note saying what the different error things here, right? Flags and local instructions apply to. I don't know what that means. Oh, it's probably a note for himself. It literally is the thing he says it is. Okay. Make this an ACK flag. Is there not a flag in the packet? Next construction. Stage primary. Oh, like a 1 or a 0 instead of a yes or a no. Is that what he means?
Yeah, looks like it, like added value.
Yeah. So while to give a context, right, while discussing this table, initially the ACK was a part of certain command types, but then we later realized that if we had an ACK as a separate bit, then we can universally apply it to whatever command we need. So the software can then choose when it wants an ACK versus when it doesn't.
So this column shouldn't exist, or it's implicit on these specific commands and can be applied to the other ones, or it has to be on these commands, I guess.
No, so yeah. So ACK required, I think that column can. I mean, if we reserve a separate bit for whether ACK is needed or not, then that column can probably be more like an implementation node that software should wait for an ACK, but we don't have to enforce anything. I mean, if software wants to speed up the process and it knows, I mean, it could probably implement a timer-based mechanism as well instead of implementing an ACK if it wants to. So then that column then becomes just a recommendation as to what it should do. But and then you have the flexibility to request or not request an ACK for all the command types.
Where do we talk about this?
I think
I see where he's talking about that column saying certain things need ACKs. Where do we talk about which bit is the
result of
ACK?
that meeting? No, we didn't talk about which bit is the ACK because at the time that column it was implicit from the command type that this command would require an ACK versus this command doesn't require an ACK. But then over the course of the discussion, we realized that if we put a separate bit in the PMR, then we have full flexibility to request an ACK or not request an ACK for any of the commands. So that's why we put a note saying that we should add it as a bit. And then in that case, that ACK column becomes just a suggestion for software to set that bit for those commands. But it doesn't have to if it doesn't
So then the ag flag should be a bit called out in table 12.
I think so. There is this PMR message type, right? So that I believe we reserved a bit for the ag flag in that table.
So if you go up a bit, Brian, to the previous page, it calls
Or
out,
Bobby
yeah.
just left a note and
The speed limit.
yeah, Bobby just left a note, and I think we'll probably have to define one. I don't recall if it already went in or not.
Okay. All right. Here. Okay. I'm gonna add this to here, so I remember that down there. And we need to add a comment up here. So, okay. All right. I think we're out of time. So I should have time this week. So I'll make a proposal here and try and clean up the whole section. And we can review that next week too. This sounds like a higher priority than some of the other things we were talking about. That makes sense?
That's awesome. Thank you.
Yeah,
All right.
sounds
Thanks,
good.
guys.
Thank you, Brian.
Talk to you next week.
Thank you. Bye-bye.